Hello and welcome to this video in which I will introduce you to the idea of dividing polynomials. You have in the past used long division to divide, say, 41 by 2. You went on to say 2 into 41 will go there 20 times, and you wrote your 20 here. And then we multiply the 20 by the 2, and that gave us 40, and we will then minus the 2 together. 41 minus 40 is going to be equal to 1. We stopped dividing here because 2 does not go into 1, and we called this number here, we called it the remainder, and we also called this number here the quotient. The number 2 is known as your divisor. Essentially, what we are saying then is that the number 41 can be written as 2, the divisor, multiplied by the quotient, which is 20, plus the remainder, which is equal to 1. So 2 multiplied by 20 will give us 40, plus the 1 will give us the 41. This argument is very important in dividing polynomials, and we will see in a later example why it is important for us to be able to write this starting number in this form here. We divide polynomials in exactly the same way as we have just done here. Suppose now that we wanted to divide this polynomial into this one here, x cubed plus 2x squared minus 3x plus 1. The way we would go about it is that we will say the highest power of the divisor into the highest power of my dividend here, which is x cubed. So x into x cubed is going to go into the x squared times, which I'm going to write there. Now we will carry on the same process as we did here. We multiplied the 20 by the 2, so it will be the x squared multiplied by the divisor, which will give us x cubed minus 2x squared, and then we will have to minus the 2 together. You will note that we do not have any terms in x to the power of 1 and any constant term here, but we could actually put place values here and say we've got 0x plus 0 going to minus the 2 together. Of course, you do not need to write these two constants or the two place values here. So x cubed minus x cubed is going to give us 0. 2x squared minus 2x squared will be equal to 4x squared, so 4x squared here. Minus 3x minus 0 is going to be minus 3x. 1 minus 0 is going to be plus 1. At this point, we are going to then repeat the process and say x into 4x squared, it's going to give us plus 4x. And then we multiply this result by the divisor again, so 4x multiplied by x, it will give us 4x squared. 4x multiplied by negative 2 is going to give us negative 8x, and then we will minus the 2 again. And if we do that, we will say 4x squared minus 4x squared, which is 0, minus 3x minus 8. So it's minus 3x plus 8x, which is going to give us a positive, it'll be a positive 5x. And then 1 minus 0 is going to be positive 1. Repeating the process again, x into 5x will be positive 5. So 5 multiplied by the divisor will give us 5x minus 10. And then when we minus the 2, this time around we will get 5x minus 5x, which is equal to 0. And 1 minus 10, it's going to be positive 11. Again, we will stop dividing here because now we are dividing an x term into a constant. As before, this means that the 11 is going to be equal to my remainder, and this term here, x squared plus 4x plus 5, will now be equivalent to the quotient, and this here is your divisor. So as before, I said that the number here that we're dividing into, which we call the dividend, x cubed plus 2x squared minus 3x plus 1, is identical to the divisor, which is x minus 2 multiplied by your quotient. In this case, it's going to be equal to x squared plus 4x plus 5, and we have to plus the remainder, which is equal to 11. You can check this at your own time, that if you expand it, it will give you my starting polynomial. And this is how we use long division to divide two polynomials. We can use this statement here, where we have now written out our original polynomial as a product of the divisor multiplied by the quotient, and we add the remainder to divide another polynomial, as shown in this new example. Suppose we are now required to find the remainder and the quotient when 6x to the power of 4 plus x cubed plus 13x minus 10 is divided by 2x squared minus 2x plus 4. We will then make use of the argument that we've just created. We said that any polynomial, in this case 6x to the power of 4 plus x cubed plus 13x minus 10, can be written in the form of the quotient multiplied by the divisor. The divisor in this case is going to be 2x squared. So if we say 2x squared minus x plus 4 multiplied by the quotient, which is going to take this form here, we will divide the highest power of the divisor into the dividend, and in this case it is going to give us an x squared. So there will be some constant which I'm going to call a, multiplied by the result of dividing the x squared into the x to the power of 4, which is x squared. Now the structure of the quotient is going to be of plus bx plus some c, and so that will be your quotient, and we will plus it by the remainder. The remainder is not always going to be a constant. It can also be a function of x, and we always stop dividing when the highest power of the remainder is now one less of your divisor. So if this is the divisor, the remainder is now going to be, well, the highest power is going to be 1 less this, so it's going to be the power of 1. So I'll insert this here, x to the power of 1, but it might have a constant here, so I could call that constant d, plus some other constant e by x to the power of 0. Now what we're going to need to do is then find the values of these constants a, b, c, d, e, and we're going to use identities to do that. If the left hand side is equal to the right hand side, then the terms in x to the power of 4 on the left should be equal to the terms in x to the power of 4 on the right hand side. So on the left hand side, we've got the coefficient of x to the power of 4 being equal to 6. So I'm going to say 6 is equal to, if I multiply this 2x squared by ax squared, I'm going to get 2ax to the power of 4. So this will be 2a. Solving this will give me 3 is equal to a. Now if we equate coefficients of x to the power of 3, on the left hand side the coefficient of x to the power of 3 is equal to 1, so 1 is going to be equal to 2x squared multiplied by bx, that is going to give us 2b, and the other x cubed term is going to be found by saying minus x multiplied by ax squared, and so it will be equal to minus a. But we've already found that a is equal to 3, so it'll be 1 is equal to 2b minus 3. And solving this will show that b is equal to 2. Now taking terms in x squared, there is no term in x squared on the left hand side, so it means that the coefficient of that term is going to be equal to 0. So we'll write 0 is equal to, on the right hand side, if you expand that, you'll see that 2x squared multiplied by c will give us 2cx squared, so the coefficient is just 2c, and minus x multiplied by the b will give us minus bx squared, so it'll be minus b, and again it'll be plus 4 multiplied by ax squared, so that coefficient is going to be 4a. Now we already know the values of b and a, so we will substitute those values when b is equal to -2, so we'll have minus 2 plus 4 lots of the value of a, which is 3, so that solving this will tell you that c is equal to -5. I'm now going to take the coefficients of terms to the power of 1, x to the power of 1. On the left hand side you can see that the coefficient of x is equal to 13, so 13 will be equal to, on the left hand side, it will be minus c multiplied by this, minus x multiplied by the c will give us minus c, and we will get 4 multiplied by the b, so that should give us plus 4b plus d, and those are the terms that contain x to the power of 1. Plugging in the values of b and c should tell us that 13 is going to be equal to, c is -5, so it'll be -5. Sorry, it's -5 because the value of c is equal to -5, plus 4 lots of the b, which is equal to 2, plus your d. And this will simplify to 13 is equal to +5 plus 8, which gives us 13, so 13 plus d. Therefore your d will be equal to 0. Finally, we are going to take coefficients of terms of x to the power of 0, otherwise the constant terms. On the left hand side, the constant is going to be equal to -10, so -10 is equal to, on the right hand side, it will be 4 multiplied by the c, so that gives me 4c, and it will just be the plus e again, which is part of that remainder, but c is equal to -5, so it'll be -10 is equal to 4 lots of -5 plus your e, and solving this will tell us that e is equal to 10. Now if we put this together, we should be able to construct what the quotient is. Remember what the question asked us to do. It asked us to find what the quotient is, so your quotient is going to be equal to, sometimes it can be written as q of x because it's a function of x, is equal to a, we found it to be 3, so it'll be 3x squared, plus bx, which is 2, so plus 2x, and plus c, which is -5, so -5, and then the remainder is d multiplied by x, which is equal to 0. So the remainder, I'm just going to write rem for remainder, is going to be equal to e, which is equal to 10. Okay, so just to recap, the objective of this tutorial was to show you how to divide polynomials. Firstly, we used long division, and then we used identities. I trust that you found it useful. Thank you for watching, and we'll see you in the next one. Cheers.